Hello, my name is Yakov. I'm a member of ICPC Analytics team, and I'm going to present you problem O. Problem O is looks like a geometry problem, and even worse, it's like a stereometry problem on a sphere. It should scare some of the teams off at first, but in fact it's much more trivial than it initially looks like. What is the problem about? We have two maps of points on a sphere, and we need to check if it is possible to to rotate one map along the normal axis from North Pole to South Pole of the planet in such a way that those maps exactly match. Now, how they are given? Now, every point is given by latitudes A and longitudes B. Obviously, there are two sets of points of size n each, and the first observation here is that if two points correspond to another pair of points on another map, then the distance between those points in both latitude and longitude should be the same. Even more precisely, the latitudes of the points should be exactly the same after they are mapped, but the difference in longitudes is what the transformation keeps in place. So the whole solution looks like this. We're going to map the lists of latitudes and longitudes into some sort of like sorted array. Let's say A, I, B, I. They're going to be sorted first by latitude and then by longitude. Actually first by longitude and second by latitude. And then we're going to apply the following transformation for it. Instead of just keeping the longitude, we're going to take the difference in longitudes between the current point and the preceding point in the sorted list. So what's going to be is AI BI minus BI minus 1. Now, the only problem remaining now is that longitude goes from 180 degrees to minus 180 degrees at some point, and the difference, of course, may be then incorrect. So what we need to do is then do it like modulo 360 in some consistent way, to make sure that at the boundary of minus 180 longitude and 180, the difference is consistent with everything else. Now we need to essentially just find a shift in indices in such a way that by rotating this sequence, we obtain exactly the same sequence of numbers. This can be solved by any string matching algorithm. For example, you may either use a hash-based string matching or KMP algorithm or anything else. It actually doesn't matter. And the complexity of this algorithm in total would be somewhere like linear of n. And n is in this problem is around 400,000. So it should fit into the time limit without any issues. That's it.